Good day, everyone. Welcome back to our discussion on the topic integration and its application. Today, we'll be discussing approximate integration. Approximate integration, that is, using the trapezium rule. Some problems in definite integral cannot be resolved with ease. They require a different approach that will be considered under this subtopic. Now, considering our diagram, the way we go about it is that we are going to be dividing each section of the area under the curve into different strips of equal widths. Now the width is going to be h. The area under the curve, which is y equals to f of s, bounded by the s axis and the ordinate s1 equals to s and s is equals to sn, is divided into strip of equal width h. Each of the strip is an approximate trapezium, and the area of a trapezium is equal to half h, which will be the height, then the sum of both parallel sides, or the sum of the two parallel sides. So therefore, finding the area of each of the strip as individual trapezium, the area under the curve, which is equal to the integral of f of s ds from sn to s1, will be approximately 1 over 2 in bracket y1 plus y2 h plus 1 over 2 in bracket y2 plus y3 h plus so on and so forth, 1 over 2 in bracket yn minus 1 plus yn h, and factorize it to be equal to 1 over 2 h in bracket y1 plus 2 y2 plus 2 y3 so on and so forth to 2 yn minus 1 plus yn, and simplifying further, it will be equals to half h in bracket y1 plus yn plus 2 in bracket y2 plus y3 plus y4 so forth and so on to yn minus 1. So this can be written as the area is equals to half the width of each strip, which is our height h, times in bracket first plus last ordinate plus 2 in bracket sum of all the other ordinates. Note that width of each strip is the common difference between the value of s, that's your s2 and s1, for each of the strip. We have another question from y 2004 that states that use the trapezium rule with 5 ordinates at s equals to 0, 0 0.25, 0 0.5, 0 0.75 and 1 to estimate correct to two significant figure the value of the integral of 1 divided by 1 plus s square ds from 1 to 0. First, we are going to be making a table of our figures to estimate it easily. Now, for the value of s, when s is 0, 0 0.25, 0 0.5, 0 0.75 and 1 plus s square, we have the corresponding value of 1.0625, 1.25, 1.5625 and 2, and 1 divided by 1 plus s square will be 1, 0 0.9412, 0 0.8, 0 0.64 and 0 0.5. Now our common difference, which our width of each individual strip, will be equal to 0 0.25 minus 0, which is equal to 0 0.25. Now our area is giving us 1 divided by 2 in bracket width of each strip times in bracket first plus last ordinate plus 2 in bracket sum of all the other ordinates, and substituting to be equals to 1 over 2 in bracket 0 0.25 times in bracket 1.1 plus 0 0.5 plus 2 in bracket 0 0.9412 plus 0 0.8 plus 0 0.64, and evaluating our bracket, it will be equals to 0 0.125 in bracket 1 plus 5, 1.5 plus 2 in bracket 2.3812, which will be equals to 0 0.125 in bracket 1.5 plus 4.7624, and adding our brackets to be equals to 0 0.125 in bracket 6.2624, and opening our bracket to be equal to 0 0.7828, approximately 0 0.78 to two significant figures. We have another question from y 2002 that states that using the trapezium rule with ordinates at s equals to 0, 1, 2, 3 and 4, estimate correct to two decimal places the value of the integral of root in bracket s square plus 9 ds from 4 to 0. Now first of all, we are going to be creating a table to estimate our values. Now for each values of s, that's when s equals to 0, 1, 2, 3 and 4, s square plus 9 will be 9, 10, 13, 18 and 25, and the square root of s squared plus 9 will be 3.1623, 3.6056, 4.2426, and 5. Now our common difference, which is our width, is equal to 2 minus 1, which is equals to 1. And our formula for our approximate integral a will be equals to half in bracket width of each strip times in bracket first plus last ordinate plus 2 in bracket sum of all the other ordinates, which should be equals to half in bracket 1 plus in bracket 3 plus 5 plus 2 in bracket 3.1623 plus 3.6056 plus 4.2426, which should be equals to 0.5 in bracket 8 plus 2 in bracket 11.0105, and expanding our bracket to be equal to 0.5 in bracket 30.021, and multiplying to be equal to 15.0105, which is approximately 15.01 to 2 decimal places. We have another question that states that using the trapezium rule with ordinate at s, which is equal to 0, 1, 2, 3, 4, estimate correct to 4 decimal places the value of b, which is equal to the integral of 1 divided by 1 plus s ds from 4 to 0. Then if the correct value of b is 1.6094, calculate correct to 2 decimal places the percentage error. Now in our solution, let us create a table to estimate our values. So for each value of s, that's 0, 1, 2, 3, and 4, we'll be estimating 1 plus s and 1 divided by 1 plus s. So the corresponding value of 1 plus s is 1, 2, 3, 4, and 5. And 1 divided by 1 plus s is 1, 0.5, 0.3333, 0.25, and 0.2. Now the common difference, which is the width of each strip, is 2 minus 1, which is equals to 1. And our formula for the approximate integration, area is equals to half in bracket width of each strip times in bracket first plus last ordinate plus 2 in bracket sum of all the other ordinates. Now substituting the corresponding values to be equals to half in bracket 1 times in bracket 1 plus 0.2 plus 2 in bracket 0.5 plus 0.3333 plus 0.2. Evaluating our brackets, it will be equals to 0.5 in bracket 1 plus 2 plus 2 in bracket 1.03333. Evaluating our bracket further, it will be equals to 0.5 in bracket 1.2 plus 2.0666, and adding our brackets to be equals to 0.5 in bracket 3.2666, which should be equals to 1.6333 to 4 decimal places. Now for the second part of our question, our percentage error will be equals to the wrong value minus the actual value divided by the actual value times 100, which should be equals to 1.6333 minus 1.6094 divided by 1.6094 times 100, which should be equal to 1.4850%, or approximately 1.49% to 2 decimal places. We have another question from NECO 2023. It states that using the trapezium rule with 7 ordinates, s equals to 2.0, 2.5, 3.0, 3.5, 4.0, 4.5, and 50, estimate the value of the integral of 2s plus 3 in bracket square ds from 5 to 2. Now for our solution, first let us make the table for the required value, and making our table for s value of 2.0, 2.5, 3.0, so forth and so on. 2s plus 3 will be 7, 8, 9, 10, 11, 12, and 13. And the corresponding value of 2s plus 3 in bracket square will be 49, 64, 81, 100, 121, 144, and 169. Now the common difference, that is the width of our strip, is equals to 2 minus 1, which is equals to 1. And from here, as for the integral of 2s plus 3 squared ds from 5 to 2 will be equals to our formula for approximate integration, which is half in bracket the width of each strip times in bracket first ordinate plus last ordinate plus 2 in bracket sum of all other ordinates, and substituting into the formula it will be equals to half in bracket 0.5, which is the width of our strip, times in bracket 49 plus 169 plus 2 in bracket 64 plus 81 plus 100 plus 121 plus 144. Now simplifying our inner bracket, it will be equals to 1 over 2 in bracket 0.5 times in bracket 218 plus 2 in bracket 510. Now 2 times 510 is 1020. So it will be equals to half in bracket 0.5 times in bracket 218 plus 1020. 218 plus 1020 is 1228. So it becomes 0.5 times 0.5 times 1238, which is equals to 309.5, or approximately 310 units square. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can easily get the hard copies in bookshop, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.